An investigation is underway following the tragic death of a 22-year-old man at Clemente Park in Fort Myers. Preliminary findings suggest the man may have been electrocuted. An external expert has been hired to investigate a potential electrical issue at the park. As a precaution, 2 power sources to the park have been shut off. The medical examiner is working to determine the official cause of death. Clemente Park will remain closed until further notice while the investigation continues. The city routinely conducts inspections of its parks. Park lighting was recently redirected after damage from Hurricane Ian, but the city states that no electrical work has been performed at the park since the storm. Electrical safety in public spaces is paramount, and investigations into potential electrocution hazards are complex. It is important to understand the basic principles of electricity to appreciate the potential dangers. Electricity always seeks the path of least resistance to complete a circuit. When a person comes into contact with an energized conductor and provides a path to ground, current flows through their body, resulting in an electric shock. The severity of the shock depends on several factors, including the voltage, the current, the duration of contact, and the path the current takes through the body. Voltage is the electrical potential difference between 2 points. Higher voltage means a greater potential for current to flow. Standard household voltage in the United States is 120 volts, but higher voltages, such as 240 volts, are used for appliances like dryers and air conditioners. Industrial and commercial settings often use even higher voltages, such as 480 volts. Current is the flow of electrical charge. It is measured in amps. Even a small amount of current can be dangerous. A current of just 10 milliamps or 1 amps can cause painful shock. A current of 100 milliamps or 1 amps can be fatal. Resistance is the opposition to the flow of current. It is measured in ohms. The human body has resistance, but this resistance varies depending on factors such as skin dryness and contact area. Wet skin significantly reduces resistance, making a person more susceptible to electric shock. Grounding is a safety measure that provides a low resistance path for current to flow back to the source in the event of a fault. Grounding helps to prevent electric shock by ensuring that metal enclosures and other conductive surfaces are at the same potential as the earth. Ground fault circuit interrupters, or GFCIs, are devices that protect against electric shock by monitoring the current flowing in a circuit. If a GFCI detects a difference in current between the hot and neutral wires, it quickly trips the circuit, cutting off power and preventing a shock. GFCIs are commonly used in bathrooms, kitchens, and outdoor areas where there is a risk of water exposure. Electrical codes and standards are in place to ensure the safe installation and maintenance of electrical systems. These codes, such as the National Electrical Code, or NEC, specify requirements for wiring, grounding, overcurrent protection, and other safety measures. Regular inspections of electrical systems are essential to identify and correct potential hazards. Over time, wiring can deteriorate, insulation can crack, and connections can loosen. These conditions can increase the risk of electric shock and fire. Qualified electricians should perform inspections and repairs. They have the knowledge, skills, and equipment to identify and correct electrical problems safely. Lockout-takeout procedures are used to prevent accidental energization of equipment during maintenance or repair. These procedures involve disconnecting the power source and placing a lock and tag on the disconnect switch to prevent someone from turning the power back on while work is in progress. Electrical safety training is crucial for anyone who works with or around electricity. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Personal protective equipment, or PPE, such as rubber gloves, insulated tools, and safety glasses, can help protect workers from electric shock and other electrical hazards. Rubber gloves are used to insulate workers from energized conductors. Insulated tools are designed to prevent electrical current from flowing through the tool to the user. Safety glasses protect the eyes from arc flash and other electrical hazards. Arc flash is a dangerous condition that could occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. Understanding the risks associated with electricity and following safe work practices can help prevent electrical accidents. The investigation into the incident at Clemente Park will likely focus on several key areas. Firstly, the condition of the park's electrical system, including the wiring, grounding, and lighting fixtures. Investigators will examine the system for any signs of damage, deterioration, or improper installation. Secondly, whether there were any code violations or safety deficiencies in the park's electrical system. Inspectors will compare the system to the requirements of the National Electrical Code and other applicable standards. Thirdly, whether the city's routine inspections of the park's electrical system were adequate and thorough. Investigators will review the inspection records to determine if any potential hazards were missed. Fourthly, the circumstances surrounding the incident, including the weather conditions and the actions of the victim. Investigators will interview witnesses and examine the scene to determine what happened leading up to the incident. Fifthly, the role of the redirected lighting fixtures in the incident. Investigators will determine if the redirection work was performed properly and if it contributed to the electrical hazard. Finally, the speed and effectiveness of the emergency response. Investigators will review the 911 call records and the actions of the first responders to determine if anything could have been done differently to save the victim's life. The investigation will likely involve a combination of visual inspection, electrical testing, and document review. Electrical testing may include measuring voltage, current, and resistance to identify any faults or abnormalities in the system. Document review may include examining electrical schematics, inspection reports, and maintenance records. The investigation may also involve consulting with electrical engineers and other experts to analyze the data and determine the cause of the incident. Once the investigation is complete, the city will likely take steps to correct any identified deficiencies and prevent future incidents. These steps may include repairing or replacing damaged equipment, upgrading the electrical system to meet current codes, and implementing stricter inspection procedures. The city may also provide additional electrical safety training to its employees and the public. It is important to remember that electricity is a powerful force that can be dangerous if not handled properly. By understanding the risks and following safe work practices, we can all help prevent electrical accidents and protect ourselves and others from harm. The investigation into the incident at Clemente Park serves as a reminder of the importance of electrical safety in public spaces. It is crucial that municipalities and other organizations take steps to ensure that their electrical systems are safe and well maintained. This includes conducting regular inspections, correcting any identified deficiencies, and providing adequate training to employees and the public. By working together, we can create a safer environment for everyone. Understanding some of the underlying electrical theory will allow a clearer appreciation of some of the terminology and facts presented here. Firstly, consider Ohm's law, which describes the relationship between voltage, current, and resistance in an electrical circuit. The law states that voltage equals current times resistance, or volts equals amps times ohms. This simple equation is fundamental to understanding how electrical circuits work. For example, if a circuit has a voltage of 120 volts and a resistance of 10 ohms, the current flowing through the circuit will be 12 amps. Secondly, consider the concept of electrical power, which is the rate at which electrical energy is transferred. Power is measured in watts. The power in a circuit can be calculated by multiplying the voltage by the current, or watts equals volts times amps. For example, if a circuit has a voltage of 120 volts and a current of 10 amps, the power in the circuit will be 1200 watts. Thirdly, consider the concept of electrical energy, which is the amount of electrical work that can be done. Energy is measured in kilowatt hours. 1 kilowatt hour is the amount of energy used by a 1000 watt appliance operating for 1 hour. For example, if a 100 watt light bulb is left on for 10 hours, it will use 1 kilowatt hour of energy. Fourthly, consider series and parallel circuits. In a series circuit, components are connected end to end so that the same current flows through each component. In a parallel circuit, components are connected side by side so that the voltage across each component is the same. Fifthly, consider alternating current or AC and direct current or DC. Alternating current is the type of electricity that is used in most homes and businesses. In alternating current, the direction of the current flow reverses periodically. Direct current is the type of electricity that is used in batteries and electronic devices. In direct current, the current flows in one direction only. Sixthly, consider transformers, which are devices that are used to change the voltage of alternating current electricity. Transformers consist of two or more coils of wire wrapped around a common core. The voltage in the secondary coil is proportional to the ratio of the number of turns in the primary coil to the number of turns in the secondary coil. Seventhly, consider generators, which are devices that are used to convert mechanical energy into electrical energy. Generators work on the principle of electromagnetic induction. When a conductor moves through a magnetic field, a voltage is induced in the conductor. Eighthly, consider motors, which are devices that are used to convert electrical energy into mechanical energy. Motors also work on the principle of electromagnetic induction. When a current flows through a conductor in a magnetic field, a force is exerted on the conductor. Finally, consider grounding, which is a safety measure that provides a low resistance path for current to flow back to the source in the event of a fault. Grounding helps to prevent electric shock by ensuring that metal enclosures and other conductive surfaces are at the same potential as the earth. These are just a few of the basic principles of electricity. By understanding these principles, you can better appreciate the potential dangers of electricity and how to protect yourself from harm. In addition to the above principles, it is important to understand some of the common electrical hazards. Firstly, consider electric shock, which can occur when a person comes into contact with an energized conductor and provides a path to ground. The severity of the shock depends on several factors, including the voltage, the current, the duration of contact, and the path the current takes through the body. Secondly, consider arc flash, which is a dangerous condition that can occur when a short circuit creates a high-energy electrical explosion. Arc flash can cause severe burns, blindness, and even death. Thirdly, consider electrical fires, which can be caused by overloaded circuits, faulty wiring, or damaged appliances. Electrical fires can spread quickly and are often difficult to extinguish. Fourthly, consider power outages, which can occur when there is a disruption in the electrical supply. Power outages can be caused by storms, equipment failures, or other factors. Fifthly, consider static electricity, which is a buildup of electrical charge on a surface. Static electricity can cause sparks and shocks, but it is usually not dangerous. Finally, consider electromagnetic fields, which are created by electrical currents. There is some concern about the potential health effects of exposure to electromagnetic fields, but the evidence is not conclusive. To protect yourself from electrical hazards, it is important to follow some basic safety precautions. Firstly, avoid contact with energized conductors. Always assume that electrical wires and equipment are energized, and never touch them unless you are qualified to do so. Secondly, use caution when working around electricity. If you must work around electricity, be sure to follow safe work practices and use personal protective equipment. Thirdly, inspect electrical equipment regularly. Check for damaged cords, loose connections, and other potential hazards. Fourthly, use ground fault circuit interrupters or GFCIs in wet locations. GFCIs can help protect you from electric shock by quickly cutting off power to a circuit if a ground fault is detected. Fifthly, do not overload circuits. Overloading circuits can cause overheating and fires. Sixthly, use extension cords safely. Do not use extension cords as a permanent wiring solution, and do not run extension cords under rugs or furniture. Seventhly, keep electrical equipment away from water. Water is a good conductor of electricity, so it is important to keep electrical equipment away from water to prevent electric shock. Eighthly, teach children about electrical safety. Children should be taught not to play with electrical outlets or equipment. Ninthly, call a qualified electrician for repairs. If you have any electrical problems, do not attempt to fix them yourself. Call a qualified electrician to perform the repairs. Finally, be prepared for power outages. Have a flashlight, battery-powered radio, and other essential supplies on hand in case of a power outage. By following these safety precautions, you can help protect yourself and others from electrical hazards. Specific to the investigation at Fort Myers Clemente Park, several potential causes could be investigated. Firstly, damaged or deteriorated wiring. Over time, wiring can become brittle, cracked, or corroded, increasing the risk of short circuits and ground faults. Secondly, improper grounding. A properly grounded electrical system provides a safe path for fault current to flow back to the source, preventing electric shock. If the grounding system is inadequate or improperly installed, it can increase the risk of electrocution. Thirdly, water intrusion. Water can significantly reduce the resistance of insulation, making it easier for current to flow to ground and creating a shock hazard. Fourthly, damaged or faulty equipment. Electrical equipment, such as lighting fixtures, can fail over time, creating a risk of electric shock or fire. Fifthly, vandalism or theft. Vandals may damage electrical equipment, creating a safety hazard. These may steal copper wiring, leaving exposed conductors that can cause electric shock. Sixthly, improper modifications or repairs. If electrical work is not performed by a qualified electrician, it can create a safety hazard. Seventhly, lack of maintenance. Regular maintenance is essential to identify and correct potential electrical hazards. Finally, code violations. Electrical codes are in place to ensure the safe installation and maintenance of electrical systems. Violations of these codes can increase the risk of electric shock and fire. The investigators will likely examine all of these potential causes to determine the root cause of the incident at Clemente Park. Their findings will help to prevent similar incidents from happening in the future. It's important to also understand the role of insulation in electrical safety. Insulation is a non-conductive material that surrounds electrical conductors to prevent current from flowing where it is not intended. The type and thickness of insulation depend on the voltage and the environment in which the conductor is used. Over time, insulation can degrade due to heat, moisture, chemicals, and physical damage. Damaged insulation can create a path for current to leak, leading to electric shock, short circuits, and fires. Regular inspection of insulation is essential to identify and correct potential problems. Specific insulation ratings, such as THHN, THWN, and XHHW, indicate the type of insulation and its suitability for different applications. THHN is a thermoplastic high heat resistant nylon-coated wire that is commonly used for general-purpose wiring. THWN is a thermoplastic heat and water-resistant nylon-coated wire that is suitable for wet locations. XHHW is a cross-linked polyethylene high heat and water-resistant wire that is used for high-voltage applications. The selection of the appropriate insulation type is crucial for ensuring the safety and reliability of electrical systems. The NEC provides detailed requirements for insulation based on the specific application. Electrical accidents can have devastating consequences, including serious injuries, fatalities, and property damage. Preventing electrical accidents requires a comprehensive approach that includes education, training, safe work practices, and regular inspections. By understanding the risks associated with electricity and following safety precautions, we can all help to create a safer environment. The incident at Clemente Park serves as a stark reminder of the importance of electrical safety.